In this video, we're going to cover the basics of a 6-bar lift. The same principles apply to a smaller 4-bar lift if you choose to build one. Ideally, when you build a 6-bar lift, you're going to have 3 bars that are horizontal to each other and parallel. So we can see these 3 channels here are my horizontal and parallel bars. And then I have 3 sets of diagonal parallel bars as well. And those bars are made out of the flats. Now, I don't have the washers and spacers and axles in here. I just have digital mates using Onshape. But the idea here is to understand the movement. So if I grab this piece right here and I use this rotational widget, we can see that the whole apparatus extends out. And the key feature here is that the diagonal bars stay parallel with each other and my horizontal bars stay parallel with each other. I will eventually reach the end, and in real life those would sort of butt up against each other and stop the movement. And we can see here that we have a minimum range and a maximum range. So I can take something and build it compact, and then I could reach out and do something. So I can maybe have a gripper or a tool attached to the end over here. Alternatively, I could pivot this. I don't know if this will pivot it properly here. I could pivot it this way, and if I was to reduce the distance here between these two ends, so using my movement here again, we can see we can go vertical. So I could use this to operate some kind of vertical scissor lift. I don't have it on the proper axis, but you can see that now that my movement is vertical, not horizontal and extending out. So what are some of the key features here? Key features are symmetry. First time you're building it, it can help to sort of imagine building it as squares. So if I rotate this a little more just to get that square shape, we can see that there is a symmetrical shape here. I get a square in the middle, followed by another square, and you can almost think of it like an accordion. There are ways to build this without having equal shapes as you go through, so a more asymmetric approach. But as you do that, you have to be mindful of the loads that you're going to place on your system. So you have to think of torque and weight and what you're trying to do at the other end. Finally, when it comes to movement of this system, you can operate this pivot point with a DC motor, you can operate it with a servo, and how you do that is up to you. You can either choose to run a gear train to operate on this axle right here to create the rotational movement, or you can use a rack and pinion setup and a servo to decrease or increase the movement and distance between this pivot point and this pivot point, depending if you want a more up and down nature or something more stationary. I recommend when doing this for a gripping arm or something that rotates out to use a series of gears here and transfer axles to rotate this main pivot point here on the channel rather than creating a torque force here at the end. Okay, so just something to think about, something to look at. Maybe you can try to build a 6-point or a 6-bar or a 4-bar lift just on your desk with parts. Make sure to use spacers and axles and the bushings and the hub collars, and just get used to how to build one of these and the movement that it gives you. Okay, so again, this is just a digital version. Feel free to build it in real life and talk to me about what you get. Thanks for watching.